Now we're going to move on to the problem with double acting cylinders, right? So double acting cylinders require air to move both ways, right? But the issue is, if they require air to move both ways, so we've got an outstroke port and instroke port. So if you apply air pressure to here, the pressure in here builds and this piston slides out the way, okay? That'll happen as long as you don't have a positive air supply here. Obviously we know that in a double acting cylinder it will happen, but it'll happen really slowly. And the other way is also true, whereby if I get the two group, right, so if you apply a signal here, that guy slides out that way, and if you apply a signal on this side, he slides back in. Hilarious. He slides back in this way. That's the double acting cylinder. If you sit it in the middle and apply air pressure both sides, it will very slowly move out because of the difference in area. So if you want to instroke this cylinder, you apply to here. If you haven't turned this one off, then you won't go that way, you'll go this way, right? There's a complexity of control that's introduced with double acting cylinders. Here's another issue. Let's say you're pretty sharp at turning your signals on and then off again so that they don't jam. You know, if you turn that output supply on and he outstrokes and you immediately turn that off, there you go, fantastic. If you want to instroke it, as soon as you provide the signal, it'll go. However, because you've turned that one off, this one's now free to move under the action of gravity or under the action of someone just physically grabbing it and pushing it back in. You know, if this was used to lift something heavy against gravity, and then you turn that signal off, gravity will just push him back down again. So it's like, well, you do want to keep the air on when you outstroke him, and only turn it off when you want to instroke him. So there's different ways to do that. Obviously, you maybe not use momentary switches. Oh, that's not what I want. You could maybe use a lever. I've got a lever drawn in here somewhere, haven't I? There you go. Yeah, so if you use a lever, remember the weird thing about that lever is it's actually, there only is one lever. If you turn the lever on one way, is this gripped? Next one. So if you turn the lever on one way, that'll open the valve up. If you turn it on the other way, or if you flick it the other way, that'll turn the valve off. Yeah, so you could have two lever valves like that. Main air, and then that guy connected here and this guy connected here. And that would work. You flick that lever, he outstrokes. As soon as you want to instroke it, you could leave that outstroke for an hour, because it's not like you're sitting with your finger on the button. And then when you want to instroke it, you need to flick that one and then open that one, and then that would instroke it. And then when you want to outstroke it, you would need to flick that one, and it gets a little bit difficult to track and a little bit annoying to control. So as much as lever valves are nice for holding air supplies, they're difficult because you then need to track what you've been doing. So lever isn't the best way to control a 5-2 valve, and that's what this is all about, controlling a double acting cylinder. So lever is not the best way. But it does solve the problem. It solves the problem of keeping the air pressure on when it's outstroked, so that gravity or the action of a person or whatever, or depending on what the context, so that thing doesn't push the cylinder back in. But we have a really good way of doing it. And a really good way is, I'm just going to grab that now. We're going to introduce a new valve. to control this guy. If I group them on it. Group. So the valve that we use to control a double acting cylinder to solve that problem of maintaining positivity or negativity in the cylinder is, it's called a 5-2 valve. So far we've met 3-2 valves and shuttle valves. This guy's called a 5-2 valve. And again, the naming convention is the same as the T2, so that means it's got 5 ports in 2 states. This time we tend to draw it horizontally. I don't know if this is going to be in the middle or not. And then again, the 5 ports are always drawn on the same state, either this one or this one. Traditionally, you always draw the 5 ports on the state on the right. Squinty much. 3 on one side and 2 on the other. Now it's considered that these 2 guys here, the 2 on the top, they're considered to be the output ports. And the one in the middle at the bottom is considered to be the input port. And then the 2 on either side of that are, yeah, you guessed it, they're exhaust ports. They're the ports through which the air that's currently in the cylinder comes out. So that's our 5 ports from the 5-2, and there's our 2 states. So in one instance, the input port is connected to that guy, and in the other instance, the input port will be connected to that guy. So that's the difference between the 2 states. Oh, for goodness sake. So there'll be main air coming out of this one when it's in one state, and then in the other state the main air will be coming out of this one. So what's nice about that is there's always main air coming out of a 5-2 valve. So if you hook these output ports up to a double acting cylinder, then the cylinder will always be held in whatever position. So if you hook it up the way it's lying just now, if the main air is coming out of this port on the right hand side, the cylinder will be held in stroked. If the main air is coming out of this one, if the air is coming out of this one, then and connected here, then the cylinder will be held out stroke. So, there's a couple of things missing from our wee diagram here. We have these things teed off. So this one will be teed off here, which means the other one will be teed off in this side. This is just a mirror image. And then this port here must be connected to the exhaust port. There you go. So this exhaust port is for that connection, and this exhaust port is for that connection. So that means that this must be happening on this side as well. There you go. So that's a complete diagram for a 5-2 valve. I might just make that guy. Right, maybe not that guy. Just make that a wee bit thicker. Come on, what's happening? There you go. Oh. I'd really like to make this guy a bit thicker. Send him to the back. There you go. The pen doesn't work on that one. Just so you can see the difference between this guy. Let me just pause this a wee second to do. Right, okay, so just to make it look a wee bit more obvious, so these are our outputs and inputs and so on. I'm just going to move that text out of the way so that we can focus on what we're talking about here, and then I should be able to move that in a little bit of a better position. So the idea behind this 5-2 valve is that we would hook the input port up to mania. There are exhaust ports, and then we would hook that guy there and that guy there. So in this position you can see that mania is connected to the in-stroke port and the cylinder is locked in position. As soon as it locked in stroke, if we change the state on the 5.2 valve, yoink, you can see now that we've changed the state, the mania has now been applied to the outstroke port, and oh, good. And the cylinder will outstroke. In this position, that happens. In this position, that happens. Alright, so this is what's happening with 5.2 valve, and what's important is when using a 5.2, the double acting cylinder will always be held in position under the control of mania. So, how do we get the 5.2 valve to change state? Well, it's exactly the same deal. We can put actuators on it. So actuators on a 5.2 valve are normally drawn, I'm just going to move this guy over because it would normally be drawn like that. That's the kind of classic way to draw the 5.2 valve. So the actuators would normally be drawn end on. So you'd have a push button, spring return. Yeah. Now that's a pretty uncommon 5.2 valve. Chances are the most common 5.2 valve you're going to see is going to be a pilot. What is pilot, I hear you ask? Pilot here is the name. Remember, you should be taking notes on this. Pilot here is the name of the air supply which goes from valve to valve. It is normally shown as a dashed line. At valve connections, it includes the little triangles pointing into the valve. So that's a pilot 5.2 valve, and we can get those pilot signals from any other valve. So what's nice about this is we could develop that pilot signal from push button spring return 3.2 valves. So those are momentary. You just tap it, just press it once and let it go, and then the cylinder will move into position and be held there by mania without us having to hold a button. Now remember, one of the other possible solutions about holding a double acting cylinder in place was the levers. So yeah, we could use lever valves to develop these pilot signals, but then we'd still have that same issue about making sure we turn the lever off before we turn the other lever on, and that control issue becomes problematic. Whereas in this scenario, that's no longer the case. So what do we think? Let's put up a circuit then. Give me a wee second. Right, okay, so we've got 4 circuits here, and what I want you to do is write them out, do a full parts list and a short explanation of operation, and then underneath I want you to give me a pros and cons. Okay, I'll start you off with circuit 1 with the pros and cons. The pro is Really, really simple control. Press the button, the thing outstrokes, let the button go, the thing instrokes. Simple control. The con is you can't leave it outstroked. If you need it to stay outstroked, you'd have to sit with your finger on the button. Okay. And then again, parts list, simple operation, and also, like, you know, let's give them numbers just to make your life easy. So that's valve 1, that's valve 1 and valve 2. It's always going to be cylinder A, valve 1 and valve 2, valve 1, valve 2, what's going on? Oh, why is it not working? So it's going to be valve 1, valve 2, and the 5-2 is going to be valve 3. What's happening? Oh, let's pause this. Okay, so yeah, these are valve 1, 2, and the 5-2 valve is valve 3. So basically what I'm hinting at is that I want you to ultimately arrive at the explanation of why we use 5-2 valves, and I've already kind of covered that in this video. And I want you to build your way up. I told you what was wrong with this type of control. I told you what was wrong with this type of control. I want you to reiterate that in your explanations of these pros and cons. So pro and con is a term that means tell me something good about it, tell me something bad about it. Okay, and that's what I'm looking for out of these 4 circuits. So I'm looking for you to sketch it. I'm looking for you to do a parts list, a very, very short description of operation because they are pretty simple. And then pros and cons, pro, positive, a good thing about the circuit is, and a bad thing about the circuit is. Thank you. And remember, the point is to ultimately tell me why we used 5-2 valves.